Groovy. Frame count has gone red, it is recording. Hello Gearstreber, wie geht's? I have just watched this Slice Arcane video, and I'll have to comment down here, but it's a lot of words and numbers, and to some people that makes it a comment full of words and numbers, and signifying nothing. It's a Shakespeare reference. Anyway, Slice Arcane here has gone over this video in which some dude has taken this bit of Wikipedia here saying the penumbral diameter is in excess of 6,400 kilometers and tried to apply that to this picture of Jupiter, which, as is pointed out in the side chat here, is a picture of part of Jupiter, not this side of Jupiter, not nearly half of Jupiter. As Sly himself pointed out, that's the red spot, and then you've got that grey stripe on one side and sort of reddish black, then white, then red on the other. Then there's a pale stripe. Well, actually the upper reddish one, it continues both sides. Then there's a pale stripe, then an orangey brown stripe, then a cream stripe, then a fat orange stripe. Then there's a hint of a cream stripe, and then more orange, then a dark red, and then pink. And on this picture, nice timing, cream, the red spot with its turbulence, greyish, white and grey, odd. And then you've got a dark bit and a reddish bit, and then cream at the top edge. So how much of that was it showing? If anything, maybe it was flipped the other way up and it was showing the lower part of this image. Anyway, Sly's ripped into it and pointed out a lot of things that are wrong with it, like it's nonsense. And, if you get the scale right, it looks more like that. But he did miss a detail. See, and it's quite a big one, in my opinion. Yes, I think it's quite big. I think I have a big one to point out for you, Sly, and somehow you overlooked it. I should stop that line of thought. The penumbral diameter is in excess of 6,400 kilometers. This is what some dude has used to claim that photograph, that one, shows the diameter of Jupiter as being tiny compared to what it really is. A partial eclipse is seen over a much larger area of the Earth. That's the big problem. Now, we're talking about the outer edge of the penumbra, and the outer edge of the penumbra is where a little tiny bit of top or bottom, as seen in the diagram, of the sun just gets hidden by the very top or bottom, as seen in the diagram, of the moon. Then in the middle of the penumbra is where the middle of the sun gets hidden, and the inner edge is where the last little bit disappears from view. And if the moon's too far from Earth, you get an annular eclipse, because this dark cone of total shadow tapers away to a point before it reaches the Earth's surface. That's it, if the moon is too far from the Earth, and the moon-Earth system is too close to the sun, you get the annular eclipse. With the moon at perigee and the Earth-Moon system at aphelion, you're going to get a total eclipse. In between, you'll get varying amounts of total eclipse, or annular eclipse. So there are a few things that affect how big that penumbra is. That proximity is two of them: how close to the Earth it is, how close to the sun it is. You can see this for yourself. Go see the shadow of one corner of York Minster shining across the shadow shining across the ground. Get a grip. The shadow of the corner of York Minster, or of any tall building, or of a lamp post beside a road. Just don't get run over measuring it. At the base, you get a very crisp shadow. Further from the top of the lamppost you are, which generally means the further away from the base of it you walk across the road, unless the sun is directly overhead, in which case you have a look on this. Further away you have to walk to get to the head of the lamppost, the more blurry the edges of the shadows get. Which is this taper that you see in this diagram on the Wikipedia, well, that's time and date. That's a time and date, not a Wikipedia, maybe. Or is it time and date image next to a Wikipedia text? I'm not sure. But in this time and date image, you have that dark taper in the middle and the grey bits at the side, and you will see that in the shadow of a lamppost. This guy, some dude, says Penumbra doesn't exist. What, mate? Someone said that. Like Rab's lad said that once, and I made a video pointing out that it does, and I've shown videos of it since, and this clown said it. But anyway, the further away your backdrop where the shadow is being cast is from the thing casting the shadow, the smaller the umbra gets and the wider the penumbra gets. So that's going to matter. How close is the moon to the Earth's surface? You also have this thing of how close it is to the light source, because the angle of this cone behind the moon, the angles of both cones, the one getting wider and the one tapering, they depend on the angular size of the sun as seen from the moon. The sun ain't changing size, it's the same sun shining on both moons, ours and Jupiter's. Well, Jupiter has dozens of the things, but on our moon and all of Jupiter's moons, it's the same sun of the same size. And especially if you get a photograph, full face of Jupiter illuminated with the shadow of the moon on it, obviously the sun's having to shine almost exactly straight past us to get that. Or it's way out on the far side of the solar system, but then you'd have a harder time getting the pictures because it'd be further away. Right. So you've got the distance to the object that casts the shadow from the light source, the distance from the object casting the shadow to the place it's casting the shadow, and you've got the size of the object. Because if you have a head of a map pin casting a shadow, and you have next to it a watermelon casting a shadow, the penumbra is going to be the same thickness, but how much of the shadow is penumbra and how much is umbra is going to be very different. And all those things will affect the size of the umbra and the size of the penumbra. And when you're looking at this picture, you're not sure how big the penumbra really is. You can see an area in the middle that's definitely umbra, and there's a tiny bit of blurring around the edges, but it's hard to see the edges of the penumbra, exactly where they are. So let's go to size. Very helpfully, NASA provide information about... Would you believe their webpage is actually live updating with the distance to Io? It clicks while you're looking at it. Give us that in a sensible unit, like kilometres, so we're in touch with everybody else. There we go. 911. It's a conspiracy. Look, it says 9/11. Must be a conspiracy. And you've got to buy the numbers page. That might be useful if it responds. Yeesh, that's ugly. Yeah. I don't want to compare it to Earth. I want to compare it to... That is a whole lot of things you can compare it to. That's a bit harsh on Bianca, isn't it? I don't know who she is. I don't know what she did to you, but she didn't deserve that. Earth's moon. Shouldn't that be listed as lunar? What do we list as both? No, it's just listed as Earth's moon. Rude. She's got a name, you know. Right. So Earth's moon is very slightly smaller. Yeah, it's 1 times larger. That's useful. Date of discovery for Earth's moon, unknown. It was pretty bloody obvious it was up there. Can't have taken people long to spot that. The average orbit distance, 421,800 versus 384,400, or, on their actual moon fact sheet, 363,300 to 405,500 kilometres. So further out, it's a larger orbit, always. Assuming it's a circular orbit. That average orbit distance is greater than the greatest orbit distance of our moon, but not by much. 363,300 up to there is less than 60,000 kilometres. 405, 500 up to there is 16,300 kilometres. Jupiter's 71,492 kilometre radius. Earth, only 6,371. So actually, as mentioned before, yeah, Io is closer to the surface of Jupiter, so you're going to have less of a band of penumbra around Io's shadow on Jupiter than you get around Luna's shadow on Earth. Sun fact sheet. You thought Jupiter was big, check out that number. 695,700 kilometres radius. Huge! And compared to Betelgeuse, to Betelgeuse, it's tiny. But, you know, that red giant is just ridiculous. So if we combine all of this together, we get the numbers in this comment. Thank you. Highlight. But again, people might not understand the comment, so that is not a diagram. That is a photograph of a car with no blue badge parked in a disabled parking space. That's a diagram, which really should have "not to scale" in big flashing letters on it. Parts of it are kinda to scale. The big yellow blob on the left and the little blue blob on the right, those have the correct size ratio for the Sun and Jupiter. The other blue blob near the middle is the same size as the blue blob on the right. The little white blob, left of the left-hand blue blob, is the correct size relative to it for the Moon relative to Earth, and the little white blob over on the right is the same size as the little white blob left of centre, making it nothing like the correct size relative to Jupiter, if we're calling that pale blue blob Jupiter. And the distances between them are obviously miles out. Actually, I should have checked whether they're literally miles out. The Sun is... got a ruler around here somewhere. What's that? Basically 700,000 kilometres. And on my screen it's 9 centimetres. So... Jupiter orbit. Perihelion, just to exaggerate, well not exaggerate, just to get the maximum number. 816,620,000 kilometres divided by Sun fact sheet 695,700 kilometres is... oops. Times 4.5, because radius, not diameter. 5282. That was in centimetres, so it should be 53 metres away. It shouldn't even be in this building, shouldn't there? What was I? There. Jupiter over there on the right, it should be at a different address somewhere further down the road. However, this does illustrate the issue of angular size. If you look at this little white blob over on the right, with this quite tight spread of yellow spaghetti from it towards the Sun, and the little white blob on the left, the much wider spread of yellow spaghetti towards the Sun and away from the Sun behind it, in each case, you can see the Sun has a much smaller angular size from over here, from over on the right, at nominally Jupiter, but it's far too close for that, than it has from over here on the left at nominally Earth, but far too close for that. Which means the penumbra is much more spread out behind Luna than it is behind Io. Which means that the greater distance from Luna to Earth's surface, the Penumbra is going to be a whole lot bigger than it is at the smaller distance from Io to Jupiter's surface, despite Io being like 4% bigger. And that means that the Penumbra size that the guy quoted from that page is wrong. I mean, you can see, typically the Umbra is 100 to 160 kilometres wide. So this is 64 to 40 times the Umbra. And when you look at, well, even when you look at that picture, you can see the Penumbra around that is nothing like 40 times as wide as the pitch black Umbra in the middle. Which, thanks for that, Hillel Finder. I really wanted the mental image of Jupiter wearing leopard print. But hey, you know, the shadow he's trying to use for a size measurement here is quite simply not the shadow whose dimensions he got there. And Sly didn't point that out, so